All right, so here I am. It's a little dark. Sorry about that. I'm going to be showing you, sharing my screen for us to do lesson 1 of our first module. So if you have your page in front of you, it is P1 and 2 from our homework book. And I am going to be sharing my screen with you. Let's see if I can find that screen. I think I forgot to open it, but I can do that really quickly here. I'm trying to remember how I did all this stuff in the past. So let's see what I can do here. There it is. Let's see if I can. Oops, share. You can hear that beeping. And there it is. This is what I'm going to share with you so that you can see what we're doing together. This should be your homework page. Move myself over here. All right, let's get this set up the right way so that you can see and I can see and we can work together. All right. How does that look for you? Pretty good. All right. Hopefully it'll stay there for us. All right, I just moved it over, didn't I? All right, so we were working on this recognizing the 10-to-1 relationship among place value positions. We were working on this in class. There it is. Trying to keep this up for you. All right. So the first question says, how do you know that 30 is 1/10 of 300? So if we were thinking about that number 30, we could even draw it out for ourselves. We would have 3 tens, and then we would have 3 hundreds. We talked about it in class. How do we know that 30 is 1/10 of 300? There are a couple of things we could put here. It is less than, 30 is less than 300. It moves one place. Which direction on our place value chart from 30 to 300? It's moved, if we're at 300 and we want 1/10 of, it's moved one place to the right. And there is one less zero. So all of those are ways that we would be able to talk about the ways we know that 30 is 1/10 of 300. All right. What number is 1/10 of 8 million? 1/10 of, if you remember, that means it's going to be greater than or less than. What do you think? 1/10 of, that's a fraction of. So it's just going to be a part of that 8 million. So that means it's going to be less. We're going to drop out one of these zeros. So from 8 million, we're going to end up with 800,000. What number is 10 times as much as 50? So here we have the word times. We should know that our number then should be bigger or be greater. So 10 times 50, we would add a 0, moving that 5 to the left in our place value chart. What number is 10 times as much as 3,000? Again, 10 times as much, we're getting bigger or greater, as we would say in math. So instead of 3,000, we're going to add a 0. We'll have 30,000, moving that 3 over to the left of our place value chart. What number is 1/10 of 30,000? So 1/10 of, remember that divided, that line in our fraction is a dividing line. So that should help us remember we need something smaller. We need part of, because fractions are part of a whole number. So we look at 30,000, we take away one of those zeros to have 1/10, and we get 3,000. This situation, number 6, math on the spot. Mark and Robin used base 10 blocks to show that 200 is 100 times as much as 2. Whose visual model makes sense? And whose visual model is nonsense? So we're looking for 200 is 100 times as much as 2. Think about that. We have 200s. They both have 200s as much as 2. How much is here? These are 2 10s. So we have 20. Here we have 2 1s. So whose model is making sense? 200 is 100 times as much as 2. 100 times as much as 2. Which model looks better? I would say that Robin's work looks better. Mark's is a little nonsensical because he's using 10s, right? And we're only doing as much as 2. So we would need those 1s. There are 2 zeros. So for 100 times, that's why we have 2 zeros to make it 200. Right? So I kind of talked through the notes here. Mark's is nonsense. He's using 10s instead of 1s. So he's using 10s. And Robin's work, I would give her the star using the correct model. All right. So if you had something written there to explain why you thought their models made sense or whose didn't make sense, I like it. All right. There are a lot of different ways we could have written some answers there. If you want to, in class tomorrow, you can share your reasoning with us. So the next side is always a test prep. This will help you know if we were ready to take a test, how would you do or would you be ready for that test? So let's see what's happening here. The first one on the back on P2 says, how does the place value of the leftmost 3 in 330 compare to the place value of the digit 3 to its right? So how does the digit in the leftmost position compare to the digit to the right? This digit is in the hundreds place, and the next one to the right is in the tens place. So how does that leftmost digit compare? What would you say? It is, so the leftmost 3 is it greater than the 3 to the right, or is it less than? Is greater. I hope you had that. It is 10 times the 3 on the right. Because it has moved one position on our place value chart, it is 10 times greater. Select all the numbers in which the place value of the digit 6 is equal to 1/10 of the place value of the digit 6 in the number 760,000. So if I locate the 6, I want 1/10 of this place. In that place, we are in the 10,000s. So if I want 1/10 of, I'm going to move over 1 to the thousands place. So I want to find any of these numbers that have a 6 in the thousands place. So here I'm looking, not A. B is a good one, 6,000. Here the 6 is in the hundreds place. Letter D, we have a 6 in the thousands place. I'll take that one. E, 600,000, not that one. And F, 2,765,400. So I think it would be B and D for number 8. What number is 10 times as much as 300,000? What number is 10 times 300,000? So it would be greater. We're going to add a 0, and it looks like we're going to have 3 million. And what number is 1/10 of 4,000? Here we need something that is part of 4,000. We take away one of those zeros and we get 400. That's it for the test prep for the lesson. The last part is a spiral review, thinking about what we already know. This should build on that. Marco is building a fence around a square garden. Each side of the garden is 8 feet long. What is the area of the garden? We have to think about the formula for area. If you remember, area is length times width. So if it's a square, we're going to have all the sides equal. So the length will be 8 feet and the width will be 8 feet. So that would give us 8 times 8 equals 64. And we say square feet. I'm going to abbreviate that right here for area, square feet. The next review, Portia has 72 postcards. This is 8 times as many as Jonathan has. How many postcards does Jonathan have? So if Portia has 72 and it's 8 times as many, does that mean she has more or less than Jonathan? It means that she has more than Jonathan. So if I think about that, I would do her 72 cards divided by 8 because he has less. And that would be equal 9. Jonathan has 9 postcards. So she has more. Arrange the following numbers in order from least to greatest. Let's look. 96,432, 94,632, 96,342. I'm going to go place by place. I need the least. They all have a 9 in the 10,000s place. Then I have a 6, a 4, and a 6 in the thousands place. 4 is less than those 2 6s. So that tells me 94,632 is our least number. I'm going to the hundreds. I have a 4 and a 3. So next I'm going to say 96,342 because 3 is less than 4. And that leaves 96,432 as the greatest number in that group. How many pairs of parallel sides does a hexagon appear to have? Parallel, if you know or remember, means that they are across from each other and they never meet. So I have parallel here. There's 1. Here would be 2. 3 parallel sides. A hexagon appears to have 3 parallel sides. All right. That is it for our, I need to stop sharing. That is it for our homework for today. If you followed along, thanks. Sorry, I'm dark here. I forgot to turn these lights back on. If you have questions, bring them for class tomorrow, and I will see you then. All right. Have a good night.